Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, this is our last lesson of chapter 5. It's called More Problem Solving, and this is where we are going to just read through some word problems. We're going to pull out the essential information. We're going to define our variables. We are going to set up our equations, and we're going to solve. So let's just get to it. So let's just get to it. We know what we're doing. Remember, this is the 5D process. The describe, pull the information out, decide what is the question asking. Then find your variables. How many of them are there? Which one are all of them being compared to? Which one can be your x? And then how do you define the relationships between the one variable and the others? And then decide on the approach that you're going to take. Sometimes even when you do set up an equation, maybe solving the equation is a little bit complicated and it might be best to set up a table and do your guess and check process. But if we can get away with doing it as an equation and solving the equation, let's go ahead and do that. Then we do the problem, we check to make sure our answer is correct, and once we feel confident, then we declare our answer using the appropriate words because these are word problems. So this whole lesson is about bugs, okay? Creepy crawly things. So 5 problems or 4 problems we're going to work through are all going to have to do with diverse animal groups. So there you go, a little paraphrase. So here's the first one. It says many insects migrate between their summer and winter homes. The desert locust migrates about 800 miles farther than the monarch butterfly every spring. And the pink-spotted hawk moth migrates about 200 miles less than 4 times the distance of the monarch butterfly every spring. So the first thing that I'm noticing is this. They're both being compared to the monarch butterfly. So I'm thinking the monarch butterfly is going to be my first variable, x. Okay, so what is the relationship between the desert locust, pink-spotted hawk moth, and the monarch butterfly? Well, let's read through this a little bit more clearly here. It says the desert locust migrates 800 miles farther than the monarch butterfly. So whatever this is, this has to be 800 more, so we'll define that as x plus 800. And then we've got the pink-spotted hawk moth migrates 200 miles less than 4 times the distance. So when you multiply that times 4, and then 200 miles less means you would take away 200. That is 4x minus 200. And then what do they say is the final total here? It says all together migrate about 12,600 miles. So that would be our total. So what is the question asking? Let me go ahead and look at this. Looks like it's asking how far does each species travel. So when we declare our answer, we're going to declare for all 3 of the distances that they go. So let's set up our table. We've got 3 different variables. We're going to start with the butterfly. That's our x because they were being compared to that. And then you've got the locust and you've got the moth with their definitions. What are we going to do with those numbers once we come up with them? We are going to add all of them together. And what are we supposed to get for a total? We're supposed to get 12,600. So I'm going to start off doing this the guess and check way. I'm going to go ahead and say the butterfly might be 5,000, which would make this 5,800. And this, oh dear goodness me, that was a bad guess. That was a bad guess because this is going to be 20,000, 19,800. Okay, I already know that's too high. This alone is way more than that. So let's scale it way, way back and go to 2,000. Which would make this 2,800, which would make this 8,000 minus 200 is 7,800. So let's go ahead and let's add all those together. I'm going to do the first 2, 4,800, and then add that to 7,800. And let's go ahead and use our calculator. The calculator 4800 plus 7800 is, oh, looky there. God, it's so nice to have lucky guesses sometimes. So that is our answer. So we can declare our answer. And I'm going to go ahead and show it right here. But I also want to solve this algebraically. Okay? So once again, if you're doing it the trial and error way, once you've got your answer is correct, then you have to take each one of those numbers. For the butterfly, 2,000 miles. For the locust, 2,800 miles. And for the moth, 7,800 miles. And you must declare the answer properly. You can't just circle numbers up in your table. You will not get full credit for that answer because you're not completing the 5D process. You must always declare your answer. All right, so let's go ahead and let's solve this algebraically. We know that we've got x plus 800, plus 4x minus 600. So when we add all those together, we get a total of 6x's. Oh, hold on for a second. Let me get a finer point here. 6x's, and then 800 minus 200 is 600. So plus 600 is equal to 12,600. So our first step would be to subtract 600 from each side, so we could find out what the 6x's were before we added the 600 in. So that means 6x's is now equal to 12,000, and when we divide 12,000 by 6, we're going to get 2,000 for our answer. So x equals 2,000. And in this case, because we did a lucky guess, we actually got our answer pretty much the same, just as easy as solving it algebraically. But depending on which numbers you choose, if the number of butterflies was 2,194, we would have been doing guess and check for a long time. But this would have taken the exact same number of steps. Combine like terms, subtract 600 from each side, divide by 6, you got your answer in 3 total steps. That's all it should ever take if you solve these algebraically. So much more efficient. All right, now let's look at bees, wasps, and ants. Bees, wasps, and ants all live in colonies that have a queen. The queen of the colony is really the mother of all the insects in the colony. During the spring and summer, many eggs are laid in bee, wasp, and ant colonies all over the world. That sounds atrocious, but whatever. I don't mind the bees so much, but those two freak me out. I don't like them. Queen bees lay about double the number of eggs in a day than queen ants lay. Okay, so far we've got bees and we've got ants. And queen wasps lay about 600 fewer eggs than queen ants do. So look what I'm noticing. Both of them are being compared to the ants. So I think the queen wasp, the queen bee, and the queen ant are going to be our 3 variables. So let's read through this again. The queen bee lays about double the number of eggs as the queen ant. If the queen ant is our x, then the queen bee would have to be twice as much as that, right? Double the number would be 2 x's. And then it says the queen wasp lays 600 fewer than the ants do. So fewer means minus, so that's going to be x. This quantity minus 600 will be the number of wasps. And what is the grand total here? 1,260. All right, so what do we have to do? Which animal or which insect? How many eggs would each the queen lay? So we are going to declare for all 3 insects: the queen ant, the queen bee, and the queen wasp. So let's set up our table. We know we're starting with the ant, then we're going to move on to the bee, then we're going to go to the wasp, and when we add all of those together, we should get 2,600. Okay, so what I would like for you to do is go ahead and fill in your table. See if you can get to the answer and then declare your answer. Then I will do the reveal and see if you got the same answer as me. Now, if you want to solve it algebraically, feel free to do that. I don't care how you get the answer. Just do whatever you need to do to make sure you get the correct answer. All right, I got my answer in my second try again. Now this is kind of interesting. I started with 1,000, then I doubled it to get 2,000, then I took away 600 from 1,000 to give me 400. Add those together, that was 3,400. That was too high, so I dropped this down to 500. This would be 1,000, but 500 minus 600 is there's no wasp that's going to lay a negative number of eggs. So we know the number of eggs that the ant lays has to be more than 600. So I just decided, all right, I'll go down 200 then to 800, and that was the winning combination. So when we declare our answer, the number of eggs that the queen ant lays is 100 eggs per day. The queen bees are 1,600 eggs per day, and the wasp is 200 eggs per day. Now let's show that algebraically. If 4x minus 600 is 2,600, and I want to know what 4x was before we took away 600, so I will add that 600 back to each side, and that is 3,200. So the 4x's must have been equal to 3,200. So what do you multiply times 3,200? Or I'm sorry, what do you multiply times 4 to give you 3,200? Well, let's divide it by 4, and you will get x is equal to 800. And so once you plug that in here, you got your 800 here, you double it for 1,600, you take away 600, you got your answer. That proves that these numbers are correct. You've decided, now you declare. All right, now let's leave the table behind and see if we can simply focus on solving algebraically. I want you to read through the problem. Then I want you to decide what are our variables, what is the question asking us, what information do they give us. Try and set it up as an equation by defining the relationships between the different variables and then solve the equation, okay? Just take some time and see if you can do that. All right, so reading through the problem, it becomes apparent that we've only got two variables. You got dragonflies and houseflies. So this is about the number of lenses that they each have in one eye. And so according to this information, dragonflies have 2,000 more lenses than 7 times the number of lenses as houseflies have in one eye. So which one, I guess the dragonfly is being compared to the housefly, telling you how many lenses it has compared to the housefly. So it seems like the housefly is going to be our x. And so the dragonfly would be 2,000 more than 7 times x. So we would write that as 7x plus 2,000. And the total that they have together when you add all their lenses together is 34,000 lenses in one eye. So what question are we being asked? How many lenses do the houseflies have? And how many do the dragonflies? So we are going to declare for both. So we need to set up the equation. So when you set up the equation, the number of housefly lenses with the number of dragonfly lenses equals the total 34,000. So let's combine like terms. X plus 7x is 8x, and 8x plus 200 is equal to 34,000. So what we need to do here is find out how many, what is 8x equal to before we add the 2,000 in. So we would subtract away 2,000 from each side, and that would give you 32,000. So what do you multiply times 8 to give you 32,000? Well, let's divide both by 8, divide especially the 32,000 by 8, and you will get our answer, which is 4,000. That means that the number of lenses that a housefly has in one eye is 4,000 lenses. Now, I don't want to just declare my answer because I need to make sure that this is correct. So what I'm going to do is I'm going to come back up to here. I'm going to multiply 7 times 4,000, which is 28,000, then add another 2,000 to make 30,000. And if 4,000 plus 30,000 equals 34,000, which it does, then we know we've got the correct answer. So we can declare our answer as houseflies have 4,000 lenses in one eye, and dragonflies have 30,000 lenses in one eye. Now for the last problem, and we will be done. The problem is about worms and buying worms from 2 different online stores. Okay, so read through the problem. Actually, do you want to read through that part? You can. It's just talking about something. So go through the process again. And I want you to notice something here. Go back to the last problem for a second. When I don't use a table, I kind of put the describe and the define together in the same section, right? This is the describe. This is what we've got going on. This defines the relationships between them. So I sort of put them together here. So you can do the same thing, okay? So go ahead, pause this, and read through all of that wonderful information at the top. Then read through this information here. Highlight the information that you know, and then define your variables. And then go to work and see if you can find the answers. Okay, so let me read it through and see if you've got the same definitions as me. John buys his worms from 2 online stores. Worm Heaven and Wiggles Are Us. John remembers that he ordered 1,200 more than twice as many worms from Worm Heaven as he did from Wiggles Are Us. So I believe we've got two different stores, Worm Heaven and Wiggles Are Us. And it seems like he's saying, what is it, 1,200 more than twice as many worms from Worm Heaven than from Wiggles Are Us. So there's more from Worm Heaven. So Wiggles Are Us has to be our variable. And Worm Heaven is going to be 1,200 more than twice whatever x is. So it becomes 2x plus 1,200. And when you add them all together, how many did he get? He got 18,000, right? So that's going to be the total. So when you add this quantity to this quantity, it equals 18,000. So we'll set up that equation. This is how many he ordered from Wiggles Are Us. This is how many he ordered from Worm Heaven. You combine like terms, you get 3x's, right? X plus 2x is 3x's, plus 1,200 equals 1,800. And now let's solve for x by subtracting 1,200 from each side, so we find out what 3x is equal to. It's got to be equal to 16,800. And then what do you multiply times 3 to give you 16,800? Well, take 16,000 divided by 3, and that gives you 5,600. So if this is truly the number of worms that he ordered through Wiggles Are Us, then we should be able to double that number and add 1,200 to it, and then add it to the 5,600, and the total will equal 18,000. So let's check that. When we take, I'm going to show you on the calculator. Oh, no, that's not it. When you take 5,600 and double it, no. 5,600, double it, and then add 1,200, you get 12,400. Okay, that's what I got right there. And now add that, where are you, calculator? There you are, to 5,600. So this should be the number that he got from Worm Heaven. Now add to that the number that he got from Wiggles Are Us. And yes, that equals 18,000. That means we feel good about our answer, and we can declare that he ordered 5,600 worms from Wiggles Are Us and 12,400 worms from Worm Heaven. So you might think that we are done doing the 5D process because this is the last lesson and we're going to get into a chapter test and then move on to a new chapter. But every word problem we solve for the rest of our lives, yes, I said it, for the rest of your lives, you need to use this process. This is the appropriate way to read through a problem, highlight the essential information, write down the relationships and define the variables, set up an equation, solve for the unknown, and then use that information to find out the rest of what you need to know, and you will be an expert problem solver for the rest of your life. All right, so that concludes, I'm thinking that's the end. Yep, that's it. That concludes our lesson for 5.3.5. Let's move on to the next activity.
Hey, feeling good, like I should. When in dark, walk